Hello everyone, myself Vangapandu Kushal from second year ECEB section. It's our case study and case study topic is low power operational amplifier. Abstract. Low power is one of the most indisciplinable criteria in several of applications. In this paper, a low power operational amplifier consists of two stages and operates at 1.8 volts power. It is designed to meet a set of provided specifications such as high gain and low power consumption. Designers are able to work at low input bias current and also at low voltage due to unique behavior of MOS transistors in sub-threshold region. This operational amplifier is designed using the Celtria 130NM technology library. The layout has been drawn and its area has been calculated. Introduction. The operational amplifier, which is also called as OP amplifier, is a core part in the designing an analog electronic circuitry and mixed signal. There are various levels of complexities when designing an operational amplifier, and thus make it a versatile device and ranging from DC bias generation to a high-speed amplification to filtering. Operational amplifier is widely used in electronic devices today as it being used in industrial scientific devices and its vast array of consumers.
Op-amps is said to be linear devices as it has nearly all the properties required for not only ideal DC amplification but also widely used for signal conducting, filtering and performing mathematical operations. Here is a small circuit diagram. A low power operational amplifier gives advantages in many applications owing to prolongation of battery life and thus makes it suitable for portable devices. In analog devices product development, it offers high power efficiency without compromising the speed, noise and precision. The second one is proposed schematic and method. The first block is an input differential amplifier and it was designed to provide high input impedance, a large CMRR and PSRR and a low offset voltage, low noise and high gain 14 to 16. The output is single ended so that the rest of the operational amplifier did not contain symmetrical differential stage, and since the transistor operating in the saturation region, there is an appropriate DC voltage difference between input and the output signals of the input stage. And the second block will perform the level shifting, added gain and single to end conversion. And here is a small block diagram of it, and there are specifications and proposed values for the diagram.
This consideration will be used to determine the width and the length of the transistor based on the proposed. Here the ratio of M3 and M4 will be found from the maximum ICMR, and M5 M6 will be found from the minimum ICMR. Here M1 M2 will be found from the transconductance, and M5 will be found from the slew rate, and M6 from gain. Design of M3 and M4 is 16 current flows to the second stage of design M3 and M4, and M7 is related to high because of same biasing. Voltage and lastly CC value of phase margin. The length of the transistor value is used when involving the two stages of amplifier. Next, here there is a calculator size of MOSFETs. They given devices types and calculator sizes. Okay. The size of M8 is optimized to 100 μm so that the gain will be increased while the value of CC is optimized to 600 FF so that GBW will increases. Other parameters can also vary such as if M1 M2 ratio is increases, the gain GML and GBW will also increases. Then if we deriving the high maximum ICMR plus, the M3 and M4 ratio needs to be high. Results and the discussion. The design of two stages of amplifier was simulated based on its different characteristics such as transistor, gain, GBW, phase margin, slew rate, CMRR, PSRR, output, offset, voltage and power distribution. These characteristics are varied using ICMR of 0.8 volt and 1.6 volt. Furthermore, the layout of the design optimized was drawn. The different results are presented here. Thank you everyone.